So I'm going to show you the box method. So the box method basically takes your, this is called your divisor, and this is called your dividend. So the dividend is the bigger number, and usually you're getting divided by a smaller number. In this case, we've got x squared and we've got x. You take a box and you put your divisor on the outside of the box. So m minus 8 is our divisor. Our quotient is going to end up here. So the answer to this division problem is going to end up on the outside of the box. So would you agree if I took 56 and divided by 7, I would get 8? But isn't 8 times 7 56? So right now, I know this number and I know this number. And when I finish, 8 times 7 will give me 56. So it's like doing the multiplication backwards. We're doing division. So our dividend is going to end up inside this box at the end. These two things are going to multiply together to give me my dividend. That's the big idea. So you're using multiplication to do the division. So if I know m squared has to end up in my box at the end, what does the first term of my quotient have to be to make it true? What has to go in this circle so that I multiply times m and I get m squared? M. So the first part of my answer is m. Now, which part of the box can I fill in? So now I know m is here and negative 8 is here. So I can fill in what this is, right? This is negative 8m down here. M times negative 8 is negative 8m. So I know what goes in that box. How many m's need to end up in my dividend? So you look back to your dividend, which is negative 7m. This plus this have to add up to negative 7. So what would have to go in this diagonal box right here so that those add up to negative 7m? Positive 1m. So you're going to put a positive 1m inside that kind of diagonal circle there. Now I can do the top of my quotient again. What has to go in my quotient so that when I multiply by m, I get 1m? What goes right here? Plus 1. So m plus 1 is my final answer. That's my quotient, but I will have a remainder. So what box can I compute now? 1 times negative 8. I can do this bottom area, right, is negative 8. What number should have ended up inside my dividend? I need it to say negative 11. Is negative 8 the same as negative 11? No, it's not. So I need to add a remainder so that these will equal negative 11. So what does my remainder have to be? Negative 3. So negative 3 I really don't care about, but negative 3 is the remainder of this problem. For doing our asymptotes, all we're going to care about is finding the quotient. And what this quotient is going to be is the graph of a line. So y equals m plus 1 is kind of like y equals x plus 1. So it's y-intercept is 1 and slope of 1. So we're going to have diagonal asymptotes on our graph. All right, so let's see if we can do another one of these. So I put my n minus 6 on the outside of this box, n minus 6, and I put n squared in the top left corner, and now I start doing my division. So what goes in my quotient first? So I'm filling in, this is going to be my final answer up here. What goes in my quotient? N, because n times n gives me n squared. What goes in the next box down? N times negative 6 is negative 6n. What has to be its diagonal partner here to get the number of n's that I have in my dividend? I have negative 1n in my dividend. I'm at negative 6n right now. So I would need to add positive 5n back to that, right? If I add these together, they add up to the negative n. So what's the final part of my quotient? N plus 5 is my final answer, but now I need to find my remainder. So I do 5 times negative 6. So I have negative 30. What do I need to add to it so that I end up at negative 29? Just 1. So I have a remainder of 1, which I really don't care about with rational functions, but it is important that there's a remainder. If there's no remainder, it was factorable, and you don't want it to be factorable. Let's try 3 together, and then maybe you can try and see if you can do number 4. These are all kind of the same level of difficulty. The functions are going to get a little bit bigger than this, but not much. So n plus 5 goes down the side, and n squared goes inside my box. What goes on top? So what is going to go in my quotient up here? N. So n times n gives me n squared. Now I do the bottom box. N times 5 gives me 5n down here. And now I need to make my dividend work out. So I need to get to 10n. I'm currently at 5n. So I need to add 5 more n inside the dividend box. So my final answer in my quotient is going to be what? N plus 5. And now I need to find my remainder. So I do 5 times 5 is 25. And what do I need to do to get to this dividend of 18? How much is my remainder? Yeah, negative 7, right? Because I'm at 25. So I have to subtract 7 as my remainder. Or you could write capital R for remainder if you don't want to write out remainder. All right, you try number 4. How many of you have done this before? Does anyone remember doing this? So no, most of your classes skipped, but you might remember this. Okay, because we did it during a virtual whatever. We did it in your class, and that was Algebra 2 CP last year. Where'd you do it with, Carmen? Last year? CP or advanced? Last year, though. Okay. So some of you might have gotten missed, but you're learning it now. So division is kind of a skill we need for rational functions. Okay, you try number 4 on your own. 4? Does that sound right? So k times negative 1, negative k goes here, negative 6k, so positive 6, and then I add 4 for my remainder. So every single time we took a quadratic and divided by a linear function and got a linear function. So I want you to look at these that are a little bit different on the back. These are now written as a rational function, which is what we're going to start seeing when we're graphing these by hand. So this is still a division problem, right? I'm taking a quadratic and I'm dividing by a linear function. So you should be able to do this one kind of the same way, but this time I think we end up with a different coefficient for our x. So we're going to put x plus 4 down the side and see how 2x squared sneaks into that top left corner. So what's going to go on top this time? What times x will give me 2x squared? What would have to go there? 2x, right. So what goes in the bottom? I have to do 2x times 4. So that is 8x. Yep, and then I have to do what to get to the 3x in my dividend? On that 8x, I would have to subtract 5 x's. So across the top, my next number is minus 5. So what's my remainder? I get a negative 20 down here. I'm trying to get to negative 1. I did negative 5 times 4 is negative 20. Positive 19 is my remainder. 19 remainder. So there's your quotient and there's your 19 that was your remainder. What's different about example h of x down below? There's something different about it. Now I'm taking a cubic function and I'm dividing by a linear function. If I just think about just taking x cubed and dividing by x, what type of function should I end up with? A quadratic answer. So depending on the degree of the function, you're going to end up maybe with not a linear function. And on this one, I want you to rewrite the numerator x cubed plus 0x squared to show that there's 0x squared minus 2x plus 9 before you start. Oops, I'm out of focus here. Okay, so I'm going to put x plus 2 down the side. It's the same process, it's just a little bit higher order function. I think we need an extra box this time, but I can't remember. So you can add a box if you need to add a box. All right, x cubed goes inside. So that's the end of what, first lunch? All right, so what goes on the top? X squared goes on top. So what goes on the bottom? 2x squared. This is why I had you rewrite your function. How many x squareds do I need? I need 0x squareds, so I need negative 2x squared to go in this box. And I feel like if you didn't rewrite the function, you might not know how many x squareds you had to begin with. But I need negative 2x squared, so that adds up to 0. Now I can continue on. So see if you can do the rest of this problem the same way. So see if you can get your quotient. There's going to be 3 terms in your quotient this time, and a remainder. Like, that's a lot of people here. Okay, negative 2x would go here, right? Because I'm trying to get to negative 2x squared. So let's see, in the bottom here, I would get negative 4x. And what am I trying to get to? I'm trying to get to negative 2x's. And I'm at negative 4x's. So I'd have to add 2 more x's. So 2x would go here. You got to stay organized. What's the last term that goes up top in my quotient? Plus 2, right? Plus 2. 2 times 2 is 4. So what's my remainder? 5, because I need to get to 9. So my quotient is a quadratic that time. All right, think about the next function. So the next function, what are you dividing by what this time? You're taking a cubic function and you're dividing by a quadratic. So what should our answer end up being? Is it going to be quadratic? It's going to be linear, right? X cubed divided by x squared in the end should be linear. How many terms are in your divisor? 3. So you need to make the side of your box able to accommodate all 3 of those terms. X squared plus 2x plus 1. I don't know how many boxes I need. I'm going to say I need 1 more. Something like that. Okay. You're going to just go at it the same exact method. So even though there's 3 terms down the side, basically just things happen a little bit faster because you're getting rid of multiple things at the same time. So you put your x cubed here. What goes on top? X. And now you have to do both of these boxes in that column on this step. So underneath the x cubed, you'd have 2x squared, right? 2x squared, and then 1x. All right, so now what am I going to look at? I'm only going to look at the next term in my dividend. See how that's negative 2x squared? So I only currently care about this diagonal right now. So to get the correct amount of x squareds, how many do I need? I currently have 2 of them. I need to get to negative 2 of them. So I would have to subtract 4 of them, right? So I need a negative 4x squared. I'm only worried about this one step right now. So what goes on top? Negative 4. And if I've made it to a constant, then that is my final answer for my quotient. My quotient is that linear function. Now I'm going to find my remainder. So for my remainder, I'm going to fill in these 2 boxes underneath this column. So that would be what? Negative 8x. Because negative 4 times 2x, and then I have to do negative 4 times 1. All right, so my remainder is actually going to be this box and this box this time. So as you look across this diagonal, all this diagonal is your x terms. How many x terms do I want? I want there to be one x in the end. There's my 1x, but I have negative 8x's here, so I would have to add 8x's up here. Does that make sense? See how that yellow line now adds up to 1x? These are all terms in my dividend. So I need 1x because this arrow right here, there's 1x in my dividend. So inside this box has to be my exact dividend at the end. So I need there to be 1x, and currently I have what, negative 7x's altogether, so I need 8x's to even it out. And what number has to go in that next diagonal? I need to get to negative 9. I need negative 5. So I actually have a remainder of 8x minus 5. So your remainder might not be a constant. I don't really care what the remainder is. So I'm not going to ask you a quiz question that's like, just divide these polynomials. You're going to be looking for this asymptote. The whole reason we're dividing is just to find that function. So if you can get that far, but you screw up the remainder, I'm not going to know. I'm not going to be checking your remainder. I think the remainder just helps you understand the process. What do you think? Should we try those for practice now, or should we do something else? Should we put them aside and see if